Good evening, this is Kavi Priya, Assistant Professor EC Department. I am going to discuss about the topic Quadrature Amplitude Modulation. So quadrature amplitude modulation is a combination of amplitude and phase modulation scheme. If the amplitude and phase of the carrier is varied, noise immunity is increased. Such a system is called as a quadrature amplitude modulation. In QAM, both the amplitude and phase of the carrier signal is varied in accordance with the digital input signal. So this is a representation of the quadrature amplitude modulation signal. It is represented as SI of t is equal to square root of 2 Es by Ts Ki cos omega Ct minus square root of 2 Es by Ts Ki sin omega Ct. So whereas Es is a symbol energy and Ts is a symbol duration. Ki and Li are a pair of constant chosen according to the location of a particular signal point. There are two orthogonal carrier signals are used here, which is represented as psi1 of t and psi2 of t. Psi1 of t is equal to square root of 2 by ts cos of omega ct and psi2 of t is equal to square root of 2 by ts sin omega ct. So we are naming it as equation 2 and 3 and we are substituting in the equation 1. So after substituting we will be getting it as Si of t is equal to square root of Es ki psi 1 of t minus square root of Es Li psi 2 of t. So the types of QAM are 4 QAM, 8, 16, 32 and 64. In 4 QAM, 4 different symbols are available. Each symbol has a 2 bits. Whereas in case of 8 QAM, 8 different symbols are available. Each symbol has a 3 bits. In case of the 16 quadrature amplitude modulation, 16 symbols will be available and 4 bits per symbol. In 32 symbols will be available. Each and every symbol has a 5 bits. And in case of 64 QAM, 64 symbols will be available and each symbol is of 6 bits. And this is a generation diagram of a quadrature amplitude modulation. The input binary sequence is given to serial to parallel converter, which is output of the serial to parallel converter is given to the digital to analog converter. So the output of digital to analog converter is given to a mixture. Other input to the mixture is a carrier signal, which is nothing but psi1 of t and psi2 of t, and the output of the mixture is being get added, which results in a quadrature amplitude modulation, which is the diagram is a generation of 16 quadrature amplitude modulation. And next is a deduction. The output of the quadrature amplitude signal is given to the mixture. So the other input is a carrier signal, which is obtained from carrier recovery circuits. The output of this mixture is given to the integrator and output of the integrator is given to the analog to digital converter. So the output of analog to digital converter is a digital signal which is given to the parallel to serial converter. So initially in case of that generator will be having a serial to parallel converter. In case of the receiver, again the parallel converter will be converted to the data will be converted back to the serial and being get transmitted. This is the constellation diagram of the quadrature amplitude modulation. We have it is given for 4-bit quadrature amplitude modulator, 16-bit and 16-bit. So next is the bandwidth of the quadrature amplitude modulator, which is nothing but 2 by n into TB. And the probability of error can be represented as 2 into 1 minus square root of 1 by root of m, and it is exponential of root of EB by n naught. And next, what are all the advantages of quadrature amplitude modulation, drawbacks and applications? Advantage is that it is a efficient bandwidth. It has a efficient bandwidth. A QAM is efficient because it can represent more bits per carrier. For example, 16 QAM maps 4-bit carrier while 256 maps 8-bit carrier. It has a high data rate. QAM can encode multiple bits per symbol, which allows for high data rate. So it is very important for applications and that require faster data rate, which such as broadband internet and high definition video streaming. And next is the scalability. QAM can be scaled to higher orders like 16 QAM, 256 QAM to increase the data throughput. Next is the compatibility. QAM is compatible with the both digital and analog system. Mainly it is suitable for variety of applications. Drawback is that it is noise sensitivity. QAM is more sensitive to noise because the transmission states are close together, and it is a complex receiver. It has a complex receiver. So QAM receivers are more complex than the other modulation types and systems. And next is the synchronization issues. QAM can suffer from synchronization issues because the receiver needs to be accurate, detect the signal's amplitude and phase. And next is a higher cost and power consumption. QAM requires more complex transmitter and receiver than the other scheme, and also cost wise it is higher and power consumption is higher. And application is that it is used in the cable television to deliver video, audio and data over the cable network. For example, DOCSIS, an international standard, uses 16 QAM 64 and 256 to provide a high-speed internet access. And next is a wireless and cellular technology. It is used to broadband digital cellular standards like LTE and WiMAX. It is also used in public safety standards like Tetra and TV white spaces like cognitive RON. And next is a radio communication system. QAM is used in radio communication systems and data delivery application. It's a good choice because it provides higher data rate, noise immunity, wide bandwidth and low error values. And next is a digital transmission, signal transmission. It is used in digital signal transmissions like digital cable television and internet services. So that's all about the generation, detection of QAM, and we have seen what are all the advantages, drawbacks and applications of QAM. Thank you.